Okie dokie. Projectiles. Whenever, in plain English, if we're talking about projectiles, we generally mean, rockets and bullets, and it often has a fairly violent connotation. In physics, a projectile is anything that moves purely under the action of gravity. So once I've chucked a ball, there's no air resistance, there's no friction elsewhere, there's no mysterious magnetic forces or electric fields or whatever. It's just gravity. And if it is only under the influence of gravity, they will form a curved path. They will form parabolas, the trajectories. It's because they have a horizontal velocity component, which will stay constant because it's not being slowed down by air drag. But the vertical component will be accelerating downwards due to gravity. So the important thing to bear in mind is we've got our cannon on a cliff, fires horizontally. If at the same time, one of the lads firing the cannon drops a second cannonball at the same time that the cannon fires, they will both reach the bottom at the same time because the vertical and the horizontal are independent. Those are two independent axes of motion. Objects always fall at the same rate vertically, regardless of the horizontal motion. Okie dokie. So, given that vertical and horizontal are independent axes of motion, it seems like a good idea to separate them out. The horizontal component undergoes uniform motion, like you would have done in sort of year 7 levels of calculation. Speed is distance over time. We don't technically need to see that for the horizontal component. The vertical component, it has constant acceleration. Acceleration is at play, so we're going to need help from our good friends, Subat. Okay, so a cannonball is fired from the top of a cliff at an angle of elevation of 25 degrees. The ball hits the sea 2.57 seconds later at a distance 58 meters away from the foot of the cliff. Good. Calculate the initial velocity of the ball, the height of the cliff. So calculate initial velocity, height, and the speed of the ball when it impacts the sea. My God, so they want they want S, but specifically in the vertical component, and the total speed of the ball hits the sea. So that's quite a complex question, so I'm not surprised it's 5 marks. Okay. Yep. As soon as you see cannonball, to be honest, you probably know it's a projectile question. That final bullet point is actually quite a good little extra bit of exam technique. I can't guarantee it'll always be the case, but often if they tell you to calculate multiple things, it's a bit of a hint as to the order in which you should calculate them. Particularly with Suvat equations, where you'll calculate one value and then use that to deduce another. It can be a bit of a lifesaver. Okie dokie. So, before. So, we've got our initial velocity as a vector, firing at an angle. To resolve that, we'll want to consider the vector components. And the whole journey takes 2.7 seconds. Important to realize that time is common to both the vertical and the horizontal. Ultimately, we can split our velocities and our displacement and our acceleration into vertical and horizontal. But don't forget that they're talking about the same object at the end of the day. Once the ball hits the water, that's the end of the journey for vertical and horizontal. So both the vertical and horizontal share the time. You can't sort of have a horizontal time and a vertical time. Okay, so the first thing we want to do is determine the horizontal speed of the cannonball. We know the distance traveled horizontally. We know how long it takes. So actually, we can determine the horizontal speed purely by our sort of velocity is distance over time equation. We don't actually, we're spared the thought of resolving vectors for a little bit. Okay, 58 meters traveled in 2.7 seconds. That makes it 21.48 meters per second. But we are asked for the total. We asked for the total initial speed. So we know what UH is, and we know that this is 25 meters per second. Right angle triangle, trigonometry. UH is going to be U cosine 25. Rearrange, and you end up with this equation. Okay, plug in your values, and you end up with 23.7 meters per second. Right, the vertical component of the speed is then given, whilst we're at it, we might as well work it out, is then given by 10.01. Ah. Right then, next on our list of things to do is the height of the cliff. Height entirely vertical, hence why it's useful to know what our U sort of vertical is. Generally, I tend to use sort of a vertical line to be vertical and a horizontal line to be horizontal, but you can also use, you know, UV or UH. It's up to you. The examiners will generally be able to figure it out. Okie dokie. We're going to break with our tradition so far and tick downwards as positive. So we're traveling a positive distance of whatever the height is. That's our unknown. U, we know what it is. We've just worked it out. V, we don't necessarily know, but we will be interested later on. We know that it takes 2.7 seconds because that's shared between horizontal and vertical. And acceleration, well, we always know what the acceleration is. It's 9.81. We didn't have to pick downwards as positive. We could have reversed the sign on U and A, and it would work just fine. Don't worry. The equation that has S, U, T, and A is the one that appears there. Rearrange, or substitute rather, because it's already rearranged to give us S. Put our values in, and we end up with 8.71. Not a super tall cliff, but, you know, scary nonetheless. And then finally, determine the vertical speed. The final speed horizontally will be the same as the initial speed because it doesn't speed up, doesn't slow down. There's no acceleration in horizontal direction. So that's fine. Vertically, we've got 4 out of the 5 pieces of information. We just need to work it out with V equals U plus AT. We've just worked out what we don't even need to use the variable. We've just calculated, but we're still using our initial velocity, which we worked out earlier. Plug those in, and you end up with 16.47 meters per second. Is that the end of the question? Not quite. It asks us for the question itself, asks us for the speed of the ball. Speed is a scalar. We need to recombine our 2 components. So we've got our sort of vertical component down and our horizontal component there. And we want to work out the hypotenuse of this triangle in order to calculate the length of this combined vector and its magnitude. The speed. Use Pythagoras. square roots, adding in quadrature. Lovely. And that answer doesn't seem totally out of whack for a cannonball, 27 meters per second.